Okay, so this week we'll be starting the SQL, right? The half of the course, basically the SQL, the coding, and the relevant information. So all these are kind of programming. The logic and everything should be here. And the first three lectures were regarding the EER normalization, and we know that EER is the starting point. The EER is the starting point to develop a database from the scratch, and normalization is another way to develop the entities and the relations from the user forms, user provided forms, views, and other things. Now, today we are studying the SQL, and so a brief history about the SQL. So one of the things is that if you're really interested, all the videos, some of the really good videos, which was prepared a few years ago. All these lectures are in the web, so definitely you can also go through those reference materials to get the detailed ideas. However, for the coding or the SQL point of view, um, I would also recommend to look at some online materials that I'll actually talk about today. Because this is the programming side, and the programming sides or the references always you need to be updated to get more ideas or what additional, a particular function can be done in different ways. So which one is optimal, this sort of thing we can try to find it out by ourselves. And nowadays it's really easy to explore, to do sort of thing. Now, some brief history about the SQL. So, okay. So, just one thing about now SQL 1 is the first standard of SQL was defined by American Standards Institute, or ANSI, in 1986, and some subsequently adopted by the ISO, International Standards Organization, in 87. SQL 2, the revised version, also called SQL 92. This is the standard that has been adopted as the formal standard language for defining and manipulating relational database. And SQL 3 covers the object-oriented features, user-defined functions, user-defined data types, triggers, etc. Okay. Now, there are two parts of the SQL, the two major components. The first component is the data definition language, or DDL, to define the database structure. And the next one is DML, or the data manipulation language, for retrieving and updating the data, right? So it has two major components. One is covering the structure. So we can imagine the create statements, insert statements, and retrieving and updating the data is most of the queries. And if we need to update. So the lecture is organized in covering all these ideas. Now, in case of data definition language, create table command, table specifications, data types, integrity constraints. We already know the basic two types of integrity constraints, and drop command. Drop command means to delete the table. Now, in terms of integrity constraints, what we know is that, for example, the primary key, right, cannot be null, or every field has an atomic value. Another is that the referential integrity, right, which means that if we want to drop a table, then we need to check that particular key is a foreign key or primary key. So it must be reference to some other table, and it can be across the database. So that is an important thing to consider. And today's lab, there are some questions covering the integrity constraints. Okay, so if we look at these commands, it's basically is defining the data at the very beginning level. Now, what is the create table statement, create table command? The create table command is used to define a new table by specifying the table and its attributes and constraints. I tried to put some of the examples into this PowerPoint, so this PowerPoint is sort of kind of updated. I'll try to keep a reference of these probably in the Moodle later on. Now, however, in the video, it is there. Now, in create table command, if we look at that statement, that create table, and one of the thing in SQL is that in terms of notation that we'll talk very soon, we would like to do a notation like we have to use the capital letter for all the construct that is used in SQL, which is the reserved keyword. So for the reserved keyword, we'll be using kind of capital letters, but it is not mandatory, right? It is free. You can use basically any type of thing, but just to maintain the consistency, we can use that. But in any company, the software companies, they use particular conventions sometimes that we need to abide by. However, in this lecture, we are using that capital letters. Now, table name, and then we can put the data types using a first bracket, using a the bracket enclosed by bracket and closed by a bracket, which means the create table and the table name starting with a bracket and closed by a bracket. And inside, we need to define all the fields or attributes. In the ER diagram, we got all the attributes. And after that, we did the also we did the normalization to get the attributes. And with transformation, we know that we know all the rules, right? All the nine steps to transform the ER or ER diagram into the tables. Then we got all the attributes like the primary key and foreign keys. One point some students asked about putting the foreign key into the ER or ER diagram. It is you don't need to. In ER diagram, you never put the foreign key. You just put the relation one to many, all the relations, and that relation itself defines, which should go where as a foreign key and so on. So you don't need to worry about that. However, in creating the table, we need to explicitly define the primary key and foreign keys, right? One of the thing is that we can put some constraint, some check. For example, if we put a data field like supplier ID, for example, I just put an example here. I can put a constraint using the check statement, right after writing that particular attribute, that the supplier ID between 100 and this value, right? So we can put a constraint. So what will happen is that when you try to insert a value into this table, then if we put any value not between 100 and 9999 for supplier ID, it will flag an error. It will throw an error and it cannot insert that data, right? So this is one of the starting level of check that we can impose while inserting the data on a table.
Mansoor,
Yes.
hi,
Somebody.
sorry. Just wanted to clarify, like you said, between 100 and 9,099.
Yep.
Uh, Normally, don't we use the type as char or number? So is that something we're going to specify over here, or is that something totally different?
No, totally different. So it's only for
Okay.
the check statement. So, I mean, definitely supply ID is a char or whatever it is, that would define in some other else, some other places, right? But under the check, what it can, I'll just give an example, but I'll give more clear example, right, in next slides.
Okay.
Okay, and the one thing is the primary key, right? Um, for this particular table, and the foreign key that is coming from another associated table, right? That is mentioned here. Of course, I haven't yet shown you the exact example, then it will be 100% clear. I'm just trying to show it here. One of the thing to know that these foreign key, we need to define here. We need to put it here as well, right? That I will show now, actually. Okay, so I'll go after a while. So first look at this particular table. Okay, just one thing I quickly jump, but I just make it clear that this foreign key, this foreign key is not part of this particular table. I mean, that we know, right, from the ER diagram. However, when you create the table, one of the field must be that foreign key, right? It can be in different spelling, right? It can be in different spelling, and that mapping must be done clearly here, right? We'll put kind of referential integrity constraints. So the references, for example, includes that which table and which particular, primary key of that particular table that is working here as a foreign key that we know is connected to that particular key, particular field, right? Uh, so that is one of the things that we need to explicitly put that foreign key here as a field, right, inside the table. Okay, so these are the two things mainly, but the other things are just as usual. Now we look at this example of create command, for example. I mean, it is basically an employee and department, and we know the relationship is one to many, right? One department may have many employees, and when you try to relate that um, from our ER diagram to the translation, to the transformation, we know that the department number we can put here as a foreign key, right? So now the question is which table I should create first, right? Which table I should create first. Now we can see that the department has the department number as the primary key, and employee has the department number as a foreign key, right? This is how they're linked. So when we have such a situation, then we must need to create the department table first. And it makes sense, right? Because this is the primary key. We need to first define that, and then we can create the employee table. So that means that we need to be careful. Of course, I mean, if you try to create the other table, then it will show throw an error. But it makes sense that first we make the independent tables, and then if we see the foreign key, then that table should be created next, right? This is the order due to the primary key and foreign key condition. Now, we'd like to create this table, and if we go through that example, then I think it should be easier. Now, while going through the example, I'll probably takes time to explain some of the characters. That is really a good discussion, and there are a lot of discussions, and you're welcome to explore in different tools, including AI tools, to explore more on those data types. Because I mean, if someone is really interested to work in database for a long time in different areas, some of you probably will be using the image, some of you will be using image is really common thing, different documents, then you need to extremely work with that particular data types, and that you need to explore more on that. Sometimes some external package can be installed and so on. Now I just go through in a simple way. So the first that I said that between these two tables we need to create the department first, that I'm doing here, and the specification is that create table department, right? Create table department. So I'm using all the capital letters, and then I'm putting the attribute. The first one is the attribute, user defined. So department number, um, and so this is a convention that is used here, that department number. So which makes sense, right? And some people are using the underscore. Everything is fine, but the notation is that, the second words is the capital letter. And varchar 2, this is really a widely used data type. Varchar 2 is actually kind of alphanumeric string. So when I put 5, which means it can have maximum 5 alphanumeric letters, right? But the first letter must be alphabet, right? And 5, not null. Not null, when we define not null, one rule is that we must have to use not null when we define an attribute as a primary key. We haven't yet defined the primary key unless in the line 4, right? Sorry, line 5, primary key department number. So we know that it is the so definitely it must be not null. Now, besides primary key, other attributes can be not null that we can explicitly define, explicitly mention. If we don't mention it, it can be null, right? Now, some other points. 5. So it is maximum 5 letters. So if I put 30, it can be maximum 30 letters, right? And we mentioned that it is case insensitive, like we made all capital letter just to distinguish between uh, the um, the system keywords or the keywords of SQL and the word generated by us, right? Whatever word we are putting on. So to differentiate them, we can use all as a capital letter, mainly for the system kind of words. Now, one thing here is that the mail number is a number type. So we'll talk about that after, I think, after few slides about all the variables more. So the number is any number. We can put like float, everything there, right? There are 3 types of notation we can define. And we can also limit the value of the numbers and so on. So some chat, sorry, I sort of missed the chat. I can open that thing. Okay. Okay, Sandeep, you may send a message. No, we can't do that, but we'll see that, right? We can use an and or, in the between. So everything must be binary, dual. Like phone number is greater than 10, and phone number is less than, is less than 20, right? Something like that we can do. Okay, now it's a good question. Now, mail number is greater than 10. We just put a constraint, which means that when we insert data for department, then if the number is not greater than 10, it will show an error, right? It will throw an error. It will not allow, basically. And the department number is a primary key. Now, data type I'll define later on clearly, but the logic of this slide, the point of this slide is to show the connection between these two tables. So the next table is the employee, right? And we are using the semicolon. So just, bracket, ended by bracket. So this is the first creatable statement. We can copy that and in our Apex, in our SQL form. And just another thing is that sometimes, very quickly, there are one online compiler or Oracle compiler. There are plenty available. Sometimes I also do that quickly, the check and everything. I mean, of course, you have to use the Oracle, the Apex environment under the, I think, the iAcademy, right? iAcademy 2. However, online tools can be quickly used. Now, employee table here, primary key is this. Now, one thing to point here is that the department number is actually the primary key. And we know that employee table should not have a department number as an attribute. But when we try to build the relationship between these two, we need to bring the department number as a foreign key. Now, to do that, we have to explicitly mention that department number as its own field, right? That is a must. And when we do that, we we mentioned the last line as foreign key, department number. So this department number refers to exactly this spelling, this one, this word, right? And then references department number. So when I type table name and the attribute, then it is clear that this department number is exactly this particular field under this department table. So although they are same spelling here, all these four words are same spelling, right? Exactly. And it is easy to do in this way, right? And it is recommended to do that. Then your matching is clear. uh, However, we need to know the difference, right? So for example, this department number is exactly this word, and this department number word is exactly that word. So if you want to change the variation, so if you do a different name here, and if then you have to use exactly that spelling here, but this spelling and this spelling must match. So this is how you can allow the variation, right? So that is the 2 points. One point is that the foreign key you must explicitly mention, and the last line must mention the foreign key referential integrity, right? The referential integrity. It can be multiple because a table can be linked with multiple tables and so on. Okay. Now an example. In case of weak entities or multi-valued attributes or M to M or inner relationships, part of all of the primary key will also form a foreign key relationship. We know that, right? Now, think about a weak entity. So in weak entity, we know that these employee ID or non should come to the dependent as a kind of composite kind of key. Of course, it is a foreign key as well, right? So then we know that the strong entity must be created first, right? And then this table. So the point of these discussions is mainly which table we need to make first. So the table which is the independent strong entities that needs to be created first, and then the other tables who are relying on one or two attributes of that particular table. We need to create that second. Now, more on the data types. We already mentioned that the primary key, it must be not null. It must be not null, right? And yeah, so assume that the employee table is already created. Only then we can create this dependent table, right? Because we are using a foreign key referencing the employee table. So before creating this statement, we first need to create the employee table, right? That is the thing. The date data type is one of the very important data type. I put additional slides to explain that because we need that even during our labs as well.
Manju,
Yep.
quick question.
Yes.
So when we say field is a primary key, so in your
Mhm.
example, if I look at line number 5 of create
Mhm.
table, we are telling the compiler that the primary key is okay, it's a composite primary key. Because I
Mhm.
was thinking if it is not a composite primary key, we don't
Mhm.
have to say not null at the field level. Because primary key, we are telling the compiler that it is a primary key. So by default, it is not null, right?
Correct.
Yeah.
Yep. Yeah. Primary key must be not null. Yep.
Yeah. So we don't
Uh,
have to explicitly say when we are declaring the field.
no, but
Uh,
we're defining not null, right?
yeah, in this case, we are because it is a composite key.
Mm-hmm.
But let's say if it is not a composite key
Then
and
not null, yeah, correct. You're right. So if it is not a composite, it definitely, you can or can, it's up to you. You may or may not, right?
right,
But
right.
yeah, if you put not null, then the problem is that while inserting the data, you cannot make it, it will not take a value. It will throw an error if I try to put a null value there. We'll see the lab examples pretty much, thoroughly those examples are explained. Now, some other things about the fields that have 1 to 30 characters. It, it cannot be huge, right? 30 characters is too much, but have to be formed alphanumeric characters with special characters, dollar sign, underscore, and hash sign. Now it just came to my mind. I think all of you have received the Apex login, and the underscore, I think, was with your uh, credentials, right? Password or name kind of thing. So probably some of you use the hyphen, right? Hyphen, not the underscore. Then it showed an error. You couldn't really log in. So that happened to some students, right? So underscore is really very common to use by many programmers. Anyway, so must begin with an alphanumeric character, cannot be a reserved word. So select, for example, select a statement or create a statement. We cannot use that as a table name, right? It makes sense. We can't do that. Now, data type specifies type of data stored in a field, arrow checking, efficient use of storage space, and we'll see different types of that in subsequent slides, character data types, number data types, and date data type. Okay, now more on that. Varchar2. So variable length character string, variable length character string with maximum of 4,000 characters that it can hold. Must specify maximum width allowed. So we must have to explicitly mention, right? We must define what is the length, 30. No trailing blank spaces are allowed. Now, this is an interesting note. For example, if you'd like to enter, I just put a word like my word and some spaces intentionally with a bracket, just single comma. So that is spaces, it will not allow. It will just, put only my word. So this space will be, discarded. So that is one of the strength of, that's its variable character, right? One of the thing, like suppose Alex, if I want to store under the varchar2, it has it has only 4 characters. So although we define as a 30 characters, which means that when it stores inside the variable, it will not take all the 30 characters, because then it will take more spaces, right? It is wasting the memory, or the storage are actually wasted. So that is the optimization inside the varchar, right? So it will automatically adjust its length, and the space will be optimally used, right? That is called basically the trailing blank space. Okay, good question, Irene. That are these rules specific to Oracle? Yes, right? It's for Oracle, explicitly for Oracle. And it's a really good point that if any database course talks about a general guideline, it will create huge confusion, right? It will create huge confusion. If I teach, for example, SQL, Microsoft SQL, then it would be different. Many of that would be different. Not many, I mean, some of them would be different, right? And so on. So that's why it's Oracle specific. Okay, now the char, another variable, right? So just even the discussion so far, we talked about varchar, that it is really, optimal, because, it is automatically optimizing the spaces, right? Shortening the spaces, and that preservation of, space is good. But char is not that good because it is kind of fixed length, but in some cases actually it is easy to use. I'll talk about that. So it has fixed length data with maximum size of 255 characters. Must specify maximum width allowed. So adds trailing blank spaces to pad width, and example declaration like this. So this is how this is the example how we can define that inside the table. Now, for example, if I put a single character like for gender, or MFU or whatever, any specification, we can use character 1, right? 1 character. And for Alex, for example, four character email into, that we already discussed. However, you can imagine that, say, state code, which is a three characters. Then for that, actually, we can use the char with three, or postcode in Australia is phone number, right? 4 character. So we can use char 4. And we know that no exception will happen here, right? Even virtually can do that, right? I mean, that's fine, but char can be used in that particular context. Now, nchar is another that is not that used. I mean, it is for the other language, multilingual support, like the Japanese kanji. They have some kind of character codex. Long is another one. We'll mainly use the number. It stores up to 2 GB of variable length character data. Each table can have only one long field. We store any doc. So blob is another one, binary large object, that is really used for the image database. For telemedicine application, telemedicine database, or medical database, they heavily use the blob data type. And for image processing, research storage, blob data is used. This is out of the scope of this course, but feel free to explore all these things. Now we proceed with the number. Another very important discussion on number. The number field optionally can have in a bracket like precision and scale. So what does it really mean? Precision is the total number of digits on either side of the decimal point, and the scale is the number of digits to the right of the decimal point. For example, if I put number 7,3, it means that it can have total 7 digits, right? Total. So if I put 7 digits, the maximum possible number is definitely 999, right? All 7 nines, right? That is the maximum possible allowable number for this particular data type, right? Whatever name you can use here, like my number, for example. So my number can have maximum that value. And the 3 indicates that after decimal, there are 3 numbers maximum, right? So this is the maximum allowable number for this particular data type. So if you really understand that, for any combination you can find it. So if I say 5, 2, it can have, I mean, you can just try to imagine that the maximum allowable number is, 5, and for 2, it must be, that thing, right? So in case of 5, 2, this is what I'm talking about, right? So this is how we can put the number. However, if we don't put any precision or scale, it can take any kind of value. There is a limit of definitely everything. I'm not quite sure, but I'm to explore. You can explore that. Okay, so that is the basic thing that we need. I also explained some of the examples. Now the number can be explained in 3 different ways. So the first, for the integer number, right? So if I define the whole number with no digits to right of decimal point, that's why it is integer number, right? Precision is maximum width, scale is omitted. So if I put number 2, so we can say that this is the age, right? So the age, the maximum value is 99, right? Because two digits maximum, right? So if you want to put 100 or any number, it will throw an error. We cannot insert that data. Fixed point numbers, which is most commonly used, right? For any item price, for example, we can put 52, which means that it can have maximum that value. So we need to be really careful, right? What numbers, what scale and precision is optimal in our context, right? That we can put based on our context, right? So 52, which means maximum 5 numbers, and 2 is the after decimal point, the 2 digits. Floating point numbers. So if I don't put anything, then it contains a variable number of decimal places. Precision is scalar omitted, and so, for example, if I put pi, so it will keep a very long number as it is. But if we define as 3 by 2, For example, it can take maximum 3.46, right? So these are the things. So fixed point numbers are commonly used. Sometimes the integer number, whatever you use in your context, you can use that. Okay, any question? Otherwise, I can proceed. That's fine. So the date is one of the most important discussion, important thing to note. Now, the date data type, it stores the dates from 11471 to BC. I don't know why did they put in this, that number. Anyway, to 12/31/471 to 80. So any date can be inserted. How did they do it? I mean, those are, I don't know, but that's really an important thing to to explore. Default data format, right? Like DDM. So this is an interesting thing to note for Oracle specifically, that this is the fixed data format that Oracle stores. All right. So the first question is then, how about other data types? So the question is this, that suppose I have a data format in one particular way, not exactly DD, MM, YY, right? In a different format. Can I insert it, right? And second type of question is, suppose my data is stored, all the dates are stored, I want to print out for the form, right? Can I use a kind of custom way to show the date? For example, the organization wants that you have to show the year first, the month next, and the date next, right? But we can see that this is the default format. How can I do it? So we have solutions for both, right? There are two functions. One is inserting data in our format to the system format. So from our format to system format. So how it will be converted to the system format, system date format, that particular function will do. We don't need to worry about that. But on that function, into that function, we need to define what way, what is the format we are trying to insert the data into, right? I'll give an example, then it will be really clear, which means that to insert from our custom format to the system format, we have one function available. And when we try to retrieve the data, when you try to show the data, show the the data inside the database, particularly the date, then can we show it in our kind of custom way? The answer is that yes, we have another function to do that, right? So we'll mainly explain those two functions. Okay, now so the default date format is this, right? For example, 05, right, minus March, 3-letter, minus 2016. Yes, good point. Input output kind function, right? That we'll go through. So if I say that s dob, date of birth, date, right? So that is a declaration by which actually we are actually allowing that particular type of thing. Data type also stores time values. Default time format is this way: hour, minute, second, am, right? So if it's an interesting point, if no time value is given when a date is inserted, default value is 12 am, right? That's interesting thing, right? Automatically that will be inserted. If we even insert only date, month, and year, the time will be 12. So when we try to show that inserted data, then we'll find that 12 is actually stored because we haven't inserted any time when we try to insert the data using the insert statement. If no date value is given, right? Sometimes I can insert only year, or the date can be null, for example, right? Can be null. So then we don't need to insert that field, that value. Then what will happen is that the default time is inserted and the date would be the first day of current month. So it will, for example, in 3rd of April, if you try to insert a data without any field, then it will automatically insert these data. Because that month is April, so you'll put 1st and 12 a.m. is the time, right? So this is the example. So this is what we're trying to see, that if we try to insert a data, then the default value is this if we try to insert that data on any day of April. Okay, I mean, this is not the only thing. More explanation will come after a few slides. Then actually we will again, we'll remind that. Now, the constraints, so integrity constraints. So used to define the primary and foreign key. So primary key constraints defined by this way, right? And we already showed that. For example, we showed here that primary key, and we can put the primary key here. Now, sorry. And defining composite primary key, so we put 2, right? In this way, or more if needed. Foreign key constraint, we define by this way, foreign key, and then the field references which table, in bracket which field. In general, they are same spelling to make it consistent, to make it easy, right? In general. Okay, so both integrity we can define in this way. And value constraint, like the check statement, suppose we define a field s gender char 1 means only 1 character, it's a fixed length. Then we are using the check that s gender equal m or s gender equal to f or anything, right? We can define whatever. Now, not null specifies that a field cannot be null, right? By using that, we already know that not null kind of thing. Okay, now drop command. This is an interesting discussion. To remove a table that is no longer needed in the database, we use the drop table command. So drop table name. Then we can use restrict or cascade. So if restrict is specified, then the table is dropped, right? Only if it is not referenced by other table. So it is dropped only if it is not referenced by other table. So cascade, if it is specified, then all reference dependents will also be dropped. So automatically it will, the chain effect will work. So for example, if we look at an example, drop table department, cascade constraints. So a table drop, so select star from employee, that field gone. I mean, I think employee last name department.
Excuse
So
me.
yes, Anna.
Sorry, before kind of pressing cascade and blowing the whole thing up, essentially,
Yep.
is there a safety thing whereby it will actually show you the other tables that it's connected to?
Yes, I mean today's lab you'll see that, right? I mean it will show the error, show the warning. Now one thing is that if you drop the primary key, for example, sorry, the table, the independent table, the strong entity, then some problem is that that reference of primary key is still as a foreign key in another table. That field will not be deleted by default. Okay. And in terms of warning, so you're saying that the cascade warning, right? No, cascade warning will not be shown. It will be just simply deleted.
Well, yes, I mean, because it may be such a complicated database that you actually have forgotten whether it's actually a table without much in the way of connections and you just do restrict, just as a fail-safe, basically.
Yeah, I mean, in case by default it is restrict, so the warning is thrown, by default. Yeah. So we'll see that more on that. Now, drop command is so this is an interesting thing, that when you drop the table, it goes to the recycle bin. Now, if we type show recycle bin, we can see the dropped table. We can get it back by we can retrieve the table by putting the command flashback table name 2 before drop. So we have to write everything and the table name, then it will come back. Now to completely delete a table from the recycle bin, we need to issue the purge command. Purge table name, then it will be completely deleted from the recycle bin. We'll be using that as well in the lab. Now create a schema kind of thing. Let's see. So DDL staying RB. I didn't understand the question. What is RB?
Sorry, recycle bin.
Oh,
Yeah.
how long? I don't know.
Yeah, normally like for the Microsoft, when you do something on the SharePoint, it have like 2 months of
okay.
area, and then it goes to the second bin.
Okay. No, in org, I don't know. I have to check the manual. Okay. Now here, so schema and the database, you can create the database. Now, of course, we have to create the database. So we are getting the Apex. You can check that. We'll do, they have some limitations, but we can create the schema, we can create the database, index, and all these commands are under the data definition language and the schema drop index. Now we start with an example, then the concepts that we went through, it would be clear. Now this is one of our, I think, lab work, the property rent, right? It's a many-to-many relationship, which means that one property can be rented by many tenants, and one tenant can rent multiple properties. Now building ID, tenant IDs, lease periods are there. So definitely it's a many to many. So this relation must have it's a separate table in which we can put the start date as another composite key, right? So the tenant ID, building ID, and start date can be a composite primary key for the relationship, right? So bond, you can see the bond. So some discussions are given here that the tenant's phone number must be recorded, right? Phone number. So if recorded, the value of the bond must be written with 2 number of digits for the scale. Lease period must be one of the 4 following, half year, all these things. Okay, now see the example. So this table, I think, looks okay to everyone, because then the building ID and tenant ID can have multiple kind of thing, right? Multiple time he can rent some same property. Okay, so which table we need to create first? So definitely the independent, sorry, the strong entity. So the property and building ID, departure 2, 5, not null, address 100, not null, and value number, primary key is the building ID. Tenant ID, departure 2, 5, not null, tenant name, not null, and address, it can be null, okay. A phone number, here, right? So primary key is the tenant ID, right? And if we do the rent, so that's an interesting thing that we define building ID, not null because it is actually the foreign key here. It's coming from the property. Tenant ID, start date not null. Lease period, voucher 220 check. So we have to check lease period in half year. So all these, right? So you must have to specify this way, right? This spelling exactly. So it can take these three, one of these three. It's a really good way to do the similar thing, right? In the database. Bond number 62, so maximum 6 nines, 9999.99, right? Maximum number. Primary key, all the three, and the reference, the 2 referential integrators, right? Which property they're referencing to, right? Good. So I think that is the starting point of the creating the structure of the tables, right? Now, in data manipulation language statement, we have insert statement, select statement, update and delete, right? In general, there is a notation that CRUD, C-R-U-D, right? Create, read, update and delete. So these are the basic kind of functionality that is relevant, similar. Now, insert statement. So when we create the table statement, the first thing we need to do, insert data. So in case of inserting the data, insert into table name, values, all the value that we need to put. So if we look at the example, that insert into department, then values D5, biology, Bandur and 33, right? So we need to know all the fields, in Apex, we can open that and then it can show. Now insert into department, we can also do this thing, right? So selected kind of, attribute we can try to insert. Of course, then we need to make sure that they are actually, the not null, right? We are putting that. No, sorry, not that. I mean, we're just specifying which field we need to put, and then the integrity constraints will be automatically be controlled by the SQL, right? For example, if we try to insert, if we do not insert a value which is not null, then it will throw an error, right? However, if we don't insert a value for a particular attribute which is possibly null, in which actually null value is possible, then it will be accepted as a null value. So when we insert the data, the other fields should then be null, right? So for example, if I put D6 and chemistry, so only these two fields will be filled up, the other fields will be null if they allow, right? Okay. Now, some examples. So the employee and the department, right? We already came with this example and we'll really go through that example a lot. Now, some discussions about the, I just put some additional thing about the date kind of thing. So I put a table like create table employee ID, right? Number, primary key, and date of birth as a date. Now insert into employee. So I put all the value and to date function. This is an interesting thing. So what happens is that I'm defining that 15 minus 05 minus 1990. This is the data I want to insert. And this is the format that I followed in this structure. Right. So whatever I'm typing in, I have to exactly type in the same way. So I use minus, two digits for date, so DD, 2 for month, so MM, right? And so on. So then the system will automatically take, and we know that this is basically how Oracle stores the data, right? Exactly. So it's okay. So, I mean, it will save in its own kind of format, which is exactly the same. But if I insert another kind of data in this particular format, 7 slash, right, 21, then I have to explicitly mention that. So then the Oracle will know that, okay, this format is like this format. So I need to translate that into that, which is the system level of date format. The toDate function will translate that. If I put this way, 1992 dot, then I have to explicitly mention that dot option. If I put like this way, March 10, 1978, I can put month, space, date, comma, year, right? Then I know that when I put full month, then the full month, but if you put MON, that also works for the first 3 letters for the month. Other options are also there, right? In the manual, you can get all possible options. And year, first 4, then October, month, and DD. So you can put that format. So what is the summary? The summary is that whatever format I want to put, I need to explicitly mention the format here inside as a second parameter of this particular function. Then it will translate to the system to the date, which is preserved inside the Oracle, right? And then when you type the select star, then you see that for all different formats, it basically preserved in this particular format, right? Inside the Oracle. So just an example, I just use this particular online compiler Oracle, just to do the experiment. You can use it to your Apex, the same thing. And now that is for inserting the data, right? For inserting the date kind of data, which means that you can use your custom date format inside the data using the toDate function. So you always need to explicitly format the data, or is there a default? So you don't have to do that. Yes, the default is exactly that thing, right? If you do that, then you can directly put that. Which is okay, it's a really good question. So for example, like this is the default format, which means that when you insert the date in the data field in the insert statement, if you directly put like 05 March 0026, then you don't need to worry about that, right? Okay, otherwise you need to do that function. Now to view, right? To view that, for example, I need a custom view of this field. So again, I am inserting the data and then I'm selecting the data. So when I select the data, so look at this statement. So I think you don't need to worry about that. It is just inserting the data like that we did previously. And then you can see on the right side that we have many different formats. We can show the data, but the system level date is definitely different, right? DD, MM, and 4Y. But I can show in different way by using a particular function called to_char. So to_char, you can see the select statement. Of course, we'll come to that point later on, but select employee ID to_char, then date of birth, and then so date of birth is actually the attribute, right? In which is a data type. So if you see here that date of birth is data, right? This is the attribute date type. Okay, so this date of birth I want to show in this particular format. DDMMYY, which is the default format, right? But in another query, we want to show our date of birth as month, DD, YYY, right? So that should be somewhere month, like this one, right? Date format 2, and I put an alias date format 2, right? Okay, and then another is YYY/MM. If I want to put, I can put this way. I can also put of this way, right? 15th of May, all this format. So any format, if you would like to show in the report, to_char is the savior, right? It will help to define that particular format. We can make it from here. Okay, so these two slides are really helpful at the beginning, so you can use that. There's another, I put that anyway. So all these are done.
So, quick question.
Yep.
So what does commit mean? Is that a keyword? Does that
It's a keyword that we'll come to that later on, right? I just generated that.
Cool.
I will discuss that later on.
Okay, and the second question is, see in the last format where it's got
Yep.
date of birth DD, DDTH, and it's got two examples. It's got 15th, 22nd. So even though we've written in the command DDTH, does it automatically pick up the correct 15th, 22nd? It
Yes.
automatically picks up the correct thing. Okay.
Yeah. So it's really powerful. I mean, it can, it knows all this thing.
Okay.
Okay, then we start with the select queries. So in case of select statement, so select attribute list. So from table list and where conditions. So if you look at this example, that select first. So I mean, we don't need to do that first. I mean, the philosophy is that select, and then you can make it blank. Then from employee, which table you want to select, right? We generally put the star at the beginning. Star means all the columns I want to show. So if I put select star means all the columns from employee table, from employee where employee non equal E1, right? So E1. And then, so if you can remember the relational algebra, that select, the tuples, E1 from the employee table, and then is a project, right? Project is two kind of columns for the first name and the last name we want to put. So this is exactly what we are trying to achieve in SQL query. Of course, I mean, this one is really easy, right, to follow. So what we do then, that what I just said, that when I write it, I wrote select. I don't care this right now. In the next line, I can write from employee, where employee ID equal to E1. So I pick everything. Now, do I need to print all or only first name and last name, right? So if I want only first name and last name, then you just put this exactly same spelling. What was the attribute? Of course, this is different. This is the alias kind of printed, but in the system level, when we did the create table statement, we use that spelling, first name, comma, last name, right? That we use, and then we can get an output like that. Of course, it's a different first, I mean, depending on, version of the Oracle as well. Anyway, so it will be printed. And this title, we can also change it. That we'll see later on. Okay, so that is the first statement, select statement, DML statement, right, in which we can query and inserted data. So we are in three phase, right? It's a three phase we completed. First is creating the table. Second is inserting the data. Third is querying. We already studied the queries, right? Now, these are the operators we can use mainly here, right? Where state, where, and then some of the clauses, equal to, less than, greater than. No, not equal is this, right? This is the, well, Oracle also supports this one, both, but this is recommended one, right? Not equal, because not equal you'll use a lot. Like statement is also really another very powerful thing. So for example, if I say where if name, first name like this, so this is a wild character. We'll explain that, right? We'll explain that. So I'll explain now probably. So like pre, which means that inside that attribute, inside that value, if in the middle of the word pre is there, right? For example, in my name, I can put Manzoor. So M, that percentage sign. So the starting with M and then any number of any combinations of alphanumeric thing, right? Or I can say that my name is, percentage R, because my name ended by R, letter R, right? So if I say that N, percentage of N, which means that in the first name, any name in which internally, I mean, in the middle or anywhere, not, if it can be end as well. So N is there, right? So for example, here, first name Mandy is okay. Daniel, yeah. So wherever I can get, I can really deal with that. Yes, case sensitive, correct. That's why I'll show another code to handle that particular situation, right?
Mansoor,
Yep.
so you can use the percentage to get all the data, isn't it, as well? This is Oracle, yeah?
Yep.
So you can put the percentage sign and do the find, and it can give you all the whatever the data is there. Like let's
Uh,
say the names associated in that column.
yeah, actually, we're dealing with here, right? So we're just trying to compare,
Yeah.
and then we're picking from the select statement. So this portion you can think is working here, right?
So you have to
I'm
use
just trying to
two
compare it.
percentage, okay, two
Uh,
percentage signs, and then put whatever you trying to
yeah.
find.
So that I'm saying. So for example, percentage 9% means that any word in which n is in the inside the word. Got it? So Mandy, n is internally internal letter, right?
Okay.
Daniel, So that is also true. That is also true. So when I say that first name like percentage and percentage, which means that this Mandy will be retrieved, Daniel would be retrieved, Annie would be retrieved, right?
Yeah.
But
Not the
these,
not the
not the other things.
okay.
Excuse me.
Yep.
In your example where you've put your own first initial or your last letter of your surname on, I think, the previous slide,
Yeah.
I'm not seeing 2 percentage signs either side of the
So this
thing
one
you're
you're saying?
nominating. Is
No, this
so
is
the
just
percentages around the bracket, around the dash,
correct.
to kind of say something between M and anything and ends in R.
Correct. Yeah.
So that was the entire command inside the inverted commas.
Yes.
Okay,
Yes,
thank
correct.
you.
Yes. Okay. So like pre, for example. So if I look at this example, that person, so of course in a comma, right? Inside the comma, we have to do everything. Percentage means any letters, any combination of letters, and pre in the middle of the word or inside the word, and then ended by other kind of words, other letters, sorry, right? And so on. There's another common in that we'll see that it tests for an enumerated list or a set. Inside a set, if that word is there, we'll see some examples, then it will be clear. Okay. Okay, so I go on. Select department number. So it's a compound comparison. So in this previous example, we saw one comparison, right? That we are trying to find the name from employee, where the employee non is E1. But now we want to see that where last name equal to Smith or last name equal to Hodges. So, I mean, we have to do in this way, right? We need to kind of write that attribute 2 times, right? We can make it bigger as well, right? We can make it bigger. So we
Manju,
want to, yep.
Sorry, can you please go back
Hmm.
to the previous slide?
Yep.
So in the operators, don't we have is operator also in Oracle?
Is, you will see that. Yes, we have.
So
We
that
have
is
that.
also an operator or it's not an operator?
No, operator.
Okay.
Is null. Yeah, true. Okay. So now here, or we are doing, so what's the point is that we are trying to put the same attribute twice, right? To make it clear. Now, or definitely we can do it using the in statement, right? So if, it is last name in is Smith or Hodges, right? We can do that. We'll see an example soon. But I think at the beginning, you can think in this way. That is easy to manage at the beginning level. So if we run this query from the employee table, it will pick only the department number of the person whose last names are either is Smith or Hodges. So this one. So D1 and D2, right? We can see that Smith is D1, Hodges is D2. So D1 and D2 is picked up with the department number, right? Okay, so that is the compound comparison. Next one is in and not in. Last name, yeah, you're right. This is, just okay. Don't follow it exactly. This is just kind of just written, but the this was the correct spelling when you created the data. That's why. Okay. That's the comment that last name should be separate because of the due to when we printed. We can put alias to put any type of format in the header, right? That was actually done. So, but internally, actually, it was last name like that when you created the data, created the table. Okay, and we follow that. Now, select department name, right? And mail number, right? From department, where department in these 2 subject. So what I'm trying to say is that exactly same way we can do the last name comparison, right? So if we do that, we try to find from the department table those tuples which have computer science and physics. So computer science and physics, D1 and D3. So department number will be printed, D1 and D3, and mail number will be printed, 39 and 37, right? So not in also is another important keyword here. So not in is, the opposite. So then actually it will be printing out information science and chemistry, right? If I put not in here. Okay, now another pattern matching search. So this is the set membership search, not in or not in is used, right? If we want to search a particular member. However, if we like to compare a particular pattern matching thing, then we have to use like, right? Or not like, the opposite. So for example, if I say that select employee non, department number from employee, where first name like N, right? So inside the word N is there. So we know if we try to compare here, the first name, that Mandy is there, right? It is true. So E1 and D1 will be printed. And then any other N, yes, any, right? E5, sorry.
But isn't it
sorry,
case
N.
sensitive? Can you say it was case sensitive so it wouldn't
Oh,
pick up?
yes, you're right. I was, correct. It is case completely 100% case sensitive. So, so small n, right? It will not take, correct. So Daniel, so AN, so E2 and D2 will be picked up, right? Due to n. All clear, everyone? So it is case sensitive, good. So what
Oh, it
about,
didn't deal with any then.
yes, that's why, right? Yeah. So what about I, percentage I? What should be the printer if I put percentage I here?
Well,
So
Daniel and
EE2,
Saskia and Annie
excellent,
have
yeah.
eyes.
And this one, E5, right? 3 will be picked up, right? Good. So now the question is that how can we deal with the case sensitive nature? Because, in real life, suppose we know that we have to find out any, but, I want to make it case insensitive, for example. I put that code on the next slide. So to deal with the case insensitive nature, there is a function, like you can see that here, that if you try to compare the where first name like N, right? So I want to transform that first name to the lower or upper, and that like can be lower or upper in the same kind of, same level. We need to transform so that we can compare it easily. So so in the coding, what I did is that if you use the lower command, that you can do it, lower first name like lower percentage of N. So you just put the lower function, so it will transform all the letters in the lowercase, right? Or you can use the upper, so everyone will be uppercase, and then you can compare it. Then basically with N, Annie will be picked up, right? And all the N, so it become then case insensitive. So you can also transform that. Any question on this particular thing? I think this is really very practical in many cases.
Quick
But if you don't
question.
want that, you can deal with the other. Yeah.
So if you do like upper AN,
Mhm.
does it make everything uppercase?
Yeah, for the comparison, right?
And yeah, for the
Yeah. For
upper,
everything uppercase,
But
and
then you
you are
should put capital A and capital N in
yeah,
the argument.
yeah. So if you do like upper and everything becomes lower uppercase, then it won't
Mhm.
pick up any, right? Because only A is capital.
That's right. The argument in the upper brackets should have capitals.
No, that's not what I'm saying. So even if you're saying like upper, it's going to make it uppercase. But what I'm saying is, if you're making everything uppercase,
Mhm.
and Annie is written as only capital A small n, is
Mhm.
it going to pick it up, or it won't pick it up because of the small n?
No, everything
We
will
are
be automatically converted.
yeah,
So, for
we are
example,
converting first name and the parameter both to uppercase and then compare
correct.
it.
Yeah.
Okay, so it would still pick it up. Okay.
Yeah.
Yeah, but then you're only comparing it to a lowercase a and a lowercase n again. That's why the argument
No,
in that
so
Inside the percentage there, okay.
No, if I, yeah, Andrew, you're right. I mean, if I want to, I mean, what is my objective? Depending on that. So if my objective is to make case sensitive, then we don't need that. Is it okay now?
Yeah, but it's not going to pick up any anyway because of that formula. Because
No, it
wouldn't
will pick up. It will pick up because
wouldn't it have to be AN%, in order to pick up any?
It's not matching the case. If you convert the Annie to upper, capital A, capital N, capital N, capital I, capital E, it still won't be picked up because you're only trying to find a lowercase a and n.
Yeah, that's why I'm doing both sides lower, right?
Yeah, I was more talking about the code we're using there. You know how you have percentage on each side and AN is in the middle? That means that Annie starts with A. Shouldn't it be a percentage to pick up Annie? Like
okay.
The first letter is missing. If it starts with a percent, it means the first letter, the AN has to be in the middle of the name. So it's not going to pick up Annie anyway. The code for it to pick up Annie would
the percent, if there is nothing in front, it will be ignored.
Yeah, correct.
The first percent or even the last percentage can either be something or nothing. The percent is either something or nothing. So it will still pick up the A and N, even with a percentage in front, because it still matches the criteria. The percentage means that it can be a wild card, it can be anything, and anything can also be nothing. But
okay, that's not what that's confusing. That's not what I thought the other thing showed us, and what we learned last term was it should be to pick up any, because it's got a percent to start with, it means there is a letter there at the beginning of the word, and the AN's in the middle.
Yeah, anyway. I think, this is a good point. That's something to test out in Oracle, right? We can test that, right? I actually tested that code, but that you said that, is it the first, is it the first one, any is picked up by the percentage at the front, that we can test, and then you can come to a conclusion, I think, right? So that's a good point. I'll also test that to make it confirmed, right? Okay. So I just gave an idea that it can be, or another alternative option is that you can put or to put all 4 possible combinations if you want to put, cap or small or whatever. Where upper change like what, like things in percentage. Okay. Okay, now, so we can see here, like X percentage, first character must be X and the rest can be anything, right? And this one, that any sequence of characters of length at least 1, which is the last character of Y.
Yeah, so that confirms what I said, that the percentage at the front can either be anything or nothing.
Null. Yeah, okay.
Right.
Yep.
But it still doesn't, it still won't pick up Annie in the last example with the upper, because you're specifically, if you go back one slide, you're converting Annie to all upper, but you're testing it with lowercase a and n. And so that the lowercase one, the lower one will work.
No, but here, if you look at Andrew here, it's small, but I converting to upper as well, right?
No, but the upper is converting. It's converting which part? Is it converting the field to upper, or is it converting that argument to upper?
Well, I mean, this n, I mean, that part is upper. So what I'm saying is that the any would be converted all to upper, and then an will be treated to compare.
Oh, yes. Sorry, no, you're absolutely right. I didn't see that upper first. I was only concentrating on the part after the like.
Okay.
You're right. You're right. Absolutely, 100%.
Okay. No, also you gave that light that I mean, it can be null as well, right?
No,
so
that's right. I mean, you're absolutely right. I was only concentrating on the part after the like. I didn't read.
Okay, no, that's okay. No, that's okay. Yeah. Okay, good. Okay, now, here we see that again percentage wise. So not like is the last character cannot be Z, right? I mean, it makes sense. So not like is also used. Now, another thing is, this is an interesting discussion about the duplicate removal. Now, we know that in SQL, when we, for example, if we put select department number from employee, if I don't put distinct, for example, it will print everything, right? all the departments like D1, D2, D2, D1 from this particular table, not this, any other table anyway. However, when I put the distinct, then it will just pick D1 and D2. So it's a kind of set operation, right? So in a sense, it is removing the duplicate thing. It is computationally expensive. That's fine, but depending on our needs, we can use that. We have to use that. Sorting. So if we try to sort the output from the queries, then is not sorted by default. So we can use order by statement to display an ordered selection. So select something. We don't need to put it at the beginning. Later we can refine the projection. From employee, order by last name. So we sort everything by last name. By default, it is ascending. But if we want to use, we can use the word descending. So order by last name, then we can put DESC here, right? DESC and then the semicolon. So that is the descending. So by default, if we don't use anything, it is ascending order. It will be sorted. Really very powerful thing for our queries. Okay. Next is aggregate function. Aggregate function. I probably after this aggregate function, I give a quick break. Then we'll try to just a 5 minutes break. So grouping output. This is a really interesting discussion here at this moment. That if we want no grouping, for example, if we type, so what is aggregate function, for example, like we can do some statistics on that, on the data. Suppose if we put select count star from employee, it will give the number of tuples, right? Number of tuples. Now, we can use that count star. When I put star, it is on every tuple. Now, what can happen is that there are 5 tuples. So in general, it will return 5, right? It will return 5. Suppose we want to insert a data, E6, Manzoor, Ashraf, and then this is null. And what I can do that on the count, I can put the department number, right? Department number to count how many, tuples are there. Then, since this is the null, it should not return 6, right? Because it is a null, so it should return 5. So this is one of the important thing. However, if we put select count star, then it will return 6, okay? Because it will then count the complete tuple. So that is one kind of note.
Can you put the distinct word there as well? So
we'll come to that. Yeah, I mean, I'm slowly, right? We can do that. Now, this is what is a simple example. Now, we can do it here. Sorry. Just one thing. Group by. So after that discussion, we can talk about that thing. That select from employee, group by department. So when I say group by, I make a partition. I make a partition with the data, right? So it will make a partition by the group by statement based on the department number, and it will treat it as 2 separate table, right? Or tuple sets, 2 separate. And it will do that calculation, like the count statement, on each separate kind of tuple set. So, for example, the first one is, if we look at here, that D1, there are three fields on the D1 and 2 tuples based on D2, right? So the count, definitely D1 for 3 and D2, 2, right? And that is actually shown here. And the department number is showing D1 and D2. So what's the point is that, I mean, what we need to know that the group by is making the group, and all these are doing the calculations on each group, right? So this is doing the calculations on each group. So it will partition the table based on department number, and then count will be applied to each partition or group. Okay, more component we can put here, which is the having statement. So to restrict a group by, use having because where clause applies to only single rows. So this is an important one. So I said that select something from employee, group by something, and having. So what does it really mean? That group by will make the group, and before group by, everything will work on individual tuple sets, individual, the tables, for example, which is the kind of virtual table you can think. And then whatever result for each group comes in, having will work on that, right? So count star 2 means D1 has, I think, if you look at here, it has 3, and D2 has 2. So it will treat this table, right? Again, the having statement will work on this particular table, right? Which is the kind of intermediate table that is generated based on the group. And when it works on that, only D1 will be picked up, right? So this is the thing. And so the where statement, now the question is where the where statement should work, right? The where statement, so select something from employee where, salary is greater than something, that will work on individual table. I will show an example after that. So I think this one is clear, this particular point. So look at here. Select department number count from employee, group by department number, having count is greater than 2. So we already went through that example. But if I want to put where statement, that works on individual tuples, right? Individual kind of group table, D1 and D2. So that will identify those employee with salary greater than 50,000. So a group by department number. So if we look at here, D1, 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 right? So in this D1 group, how many of them has 50,000, more than 50,000? I think it's only 2. 2, right? Yeah, 2. D1 is 2, and you can see the D1 is 2, and D2 is 2. So only one of them has 50, greater than, more than 50,000. So it should be 1, right? 1. Okay, any question on that? I think it now makes sense, right? So on each group, we are applying the where statement, right? So that is one of the thing we need to look at, right? So having is applied after the relation or table is made. Having is applied, and where is applied, inside each table before the grouping, basically, right? Before the grouping. Okay. Some other aggregate functions like count, we already talked about, and now a interesting concept as, right? As is alias. So for example, if I don't put as here, so count star will show here. So total number of employee where salary is greater than 50,000. So 3 of them have more than 50,000, 3. So I want to show not count. So if I put, like count star, for example, so it will be shown like that, actually, like something like that. It will be here. So instead of count, I want to put some meaningful thing like a high salary, right? Even you can put double quotation. I'll show that. Like total you can put double quotation like total high salary, for example. So what you can do, this one, like total high salary, you can directly put here. And if you don't put double quotation, you can put underscore. Then as a single word, it will be printed. That is also, if whatever you want, you can do that. Okay, you can either use this or that. So high salary, so 3 of them has high salary, for example. That is what is shown here using the as keyword. Okay, the sum is an interesting one. So select count as high salary, sum salary, sum is summation, right? As total high salary from employee where salary is greater than 50,000. So if we look at here, that 3 of them have 50,000, and we need to make the summary, the summation. sorry, the summation of salary of 3 people, and that is the 182. Okay, right? And for each attribute, we are using the as keyword to define a meaningful kind of, words, to define meaningful words, right? That's why as is actually used. So one thing, as is used to basically print the attribute in a meaningful way, or whatever way we want to print out. As will never be used for the table name, right? Some confusion can happen. For the table name, we can use another notation that will be using a character or something, and then we'll deal with that. Okay, any question up to this point? I think we're just going through the basic first, then the complicated thing will.
So,
yep.
Sorry, Mansur, you have used like as in the capital letters over there, and then in the smaller letters after the
Anything
salary.
you can do. Yeah, you can use in that. I'm saying that this notation is you can use anything, right? But for that is actually done, as in why it is done, I'm not sure, but everything should be capital, but both will work. Even if you select all the small letter, it will work. Okay, so it's case what you can say case.
So it's not case sensitive.
Case insensitive, right? Okay.
Okay, thank you.
Now, mean, max, average, really powerful kind of construct that select mean salary as, you can define max, average from employee. It can give this data, right? So all these are aggregate function, mean, max, count, right? So far we did. In count, we know that in one column are all tuple, and we came with across many other things. Now, one of the things, then I give a break. So mean, max in general works with numbers, right? We know that it makes sense, mean, max. But in Oracle, you can also apply that mean, max with the alphanumeric characters. So when you do that, and you all know that A, B, C all sort is there. So based on that, alphabetically which is smallest, it will be printed first, right? And so on, right? So mean first name will return Alice from this data, and max first name will return Charlie, right? So it will be it will work on even the varchar as well, right? Varchar 2 as well. Okay, so just a quick break, probably 5 minutes, then we can finish that. Okay, just 5 minutes. Okay, it's now more aggregate function continuation. So select department number, minimum salary. So within that statement as minimum salary, we define, put an alias. Max salary as max and average salary as average from employee, group by department number, right? So we can pick all things. So when I put the group by department number, it will make the partition and do all the average, minimum, and max on the corresponding tuples, right? And this is the output. So based on the partition group by department number, all aggregate functions will be applied. Okay, even we can put complex at the beginning as well, complex queries. Now, we already discussed two chars, so I don't want to discuss that. And I put some examples before. To date as well, we discussed. Now, the subqueries. So subqueries is a complete SQL statement embedded within another select statement. The result of the inner statement, select statement, is used in the outer statement to help determine the contents of the final result. So which means the inner statement will be executed first, then the outer statement. For example, if I type select first name, last name from employee, where department number equal, and then we put a query, another query, right? That's an interesting one. So I could write only department number, for example, depending on what we want to achieve, right? Say the department number from the department table, I want to pick the corresponding tuple, which has the mail number 39. So if you see here that select department number from the department where mail number equal to 39, right? So by this query, this is just an example. So by this query, it will pick up the corresponding department number, just one field. Remember that one field, which has mail number 39, right? Now, the question is, in some context, it can have multiple tuples, right? Just for the sake of argument, we can assume that it's only one tuple it is returning, right? So if it returns only one tuple, then actually it works, this equal sign. So again, this equal sign only works for only one tuple if that returns. So what it is returning, it is actually returning only one department number. So if I put the department number, then these three lines make sense, right? That select first name from employee, where department number equal to say 10, for example. And that 10 came by executing this query. That select department number from department where mail number. So this is actually coming probably from another table, right? So which means from one table or from the same table, we can pick a value and that we put into another outer query, right? So this is the outer query and this is the inner query, right? So the inner query will be executed first and then the outer query. Okay, what option we can do here? For example, if I say that select department number for the inner query from department where mail number equal to 39 or mail number equal to 30. So it is clearly shown here that it will definitely return at least two tuples or two department numbers. So if I put return two department numbers, this equal sign will never work, right? So then it will throw an error, this query. So how to deal that? Sometimes we want to find out those employees who are working under these two department, right? We want that. Then actually we need another keyword, which is the in statement. We'll see in the next slide. Okay, before going there, any question on here, like the inner and outer query?
Or can't we do that? We can put it all separate, like small separate queries, and then try to find the employee thing.
Then when we'll go through the PLS to some of the programming, then we can do that.
Okay.
Got it. But this is sometimes easy. Of course, we'll some other examples as well.
Because if you
whatever you
find,
like, whatever you like,
if you want to find 3-4 columns separately, I mean all together, then it might
that I'm
make
saying
the
when we
statement
do
complex.
Yeah, when we'll do the store procedure or the PLSQL, then it's a pure programming. Then you can do what you want. Okay. So right now, actually, this is the kind of easy option. Now, what I just said, that if we return more than one, then we can use the in statement instead of minus sign. So an example is this. So that's the nested subquery. So select statement from employee where department number in, select department number from department where location equal to Bandura, right? So if we look at the inner query first, then we return more than one department numbers, right? So if we look at from the data, Bandura, is it the data? Oh, yeah. So Bandura 2, so this D1 and D3, right? D1 and D3 is returned. So which means that the statement becomes something like that. Select these from employee where department number in D1 and D3. D1 and D3. So if we look at D1 and D3, under employee, so you see we are dealing with two tables, right? Inner query in one table and outer query in another table, right? So just try to, the best thing is to simplify the concept, right? So in the outer table, we can see that the first name and the last name from the employee pick only those who are in D1 and D3, right? Bandura, yeah, D1 and D3. So D1 and D3, there are no D3. So Mandy will be printed, right, for this particular case. Bandura. Anyway, based on that I can see. Okay.
Yeah, it only produces what's on D1 because there's nothing in D3 in that second table. And that's why it lists
okay. I didn't notice that. Sorry, yeah. So all these three, yeah, correct. Yep. Because we pick the D1 has 3 instances, and that will be printed. That's good thing, Andrew. Yeah, thanks. Yep. I was confused. Anyway, so the next one is a kind of similar example, but kind of different way to write it down. Select first name, last name. This is interesting. Salary minus. So we are doing a big kind of calculation here. So what we're doing is that we are trying to make the difference of salary, right? So we just go it first. Probably ignore that at present. We want to do some logic that we put salary difference from the average, for example, right? That is our objective. From employee where salary is greater than, select average salary from the employee. So the previous table worked on 2 different tables, inner and outer, but this one is the same table. So from the same table, we try to find in the inner query the average salary, and we are trying to pick those employees where salary is greater than the average salary. And also, so if we even don't do that, if we just put the first name and last name, this will be printed, right? These 2 columns will be printed. And when you do this query, then that minus the difference from the average will be printed here. So it's a really good way to know what's really happening, right? So the main point is that even we can execute a query here, right? We can execute a query here. Okay. Now the next one is join. Now this is really very quickly, I have to go, but this is really a powerful thing. Now in join, is a Cartesian product. I think we did that in relational algebra, that when you join it, all possible combinations will be there, and many kind of not meaningful things will appear, and that will be discarded by this third sentence. For example, if I join employee and department table, then all the entities will be combined with all possible combinations, and then I'll only pick up those where in both tables department number are same, right? This in the join clause, we have to put n-1 join clauses if we join n tables. Like for example, here we are joining 2 tables, there is only 1 clause. For 3 tables, there must be 2 clauses. We'll see that 2 clauses. Now, as an example, suppose employee table and this is the department table. When I join them using the comma, and we put that notation E and D, right? So we define that, and then we can use that E dot the attribute, right? In this way, we can define the query. So when we do it, all the attributes I can write in this way. And then, mentioned at the start of this lecture, different questions recording. Yeah, the reference. Okay, I didn't understand, Anna.
Sorry, I didn't mean to interrupt your speaking.
Yeah.
Right at the beginning, when you introduced this evening,
Yep.
you mentioned that there are recorded lectures on the LMS.
Oh, yeah. That's already there.
They're not quite up to date, and that you would give us some references to materials that would bring us up to date. So that's what I was just wanting to remind.
Oh, I see. Yeah. Now, reference, I mean, during the lecture, I talked about like some external online tool, right? And so on. But some of the reference, later probably I'll post under that week.
Could you please
Some of the external websites, right?
Yes.
Yeah. Even, I mean, these programming websites, there are many, I mean, plenty of, like W3 schools and some of the things where actually you can, learn that. For the beginners, basically, I strongly suggest to go through that.
Your recommendations would be appreciated rather than me Googling for hours and looking at reviews.
Okay, no, that's okay. Yeah, W3 schools that I can strongly recommend, right? Just to get the ideas. But sometimes
What was that you said?
W3 schools. So I can write it down, right?
Please, yeah. Did this lecture start at 5?
Yes.
Right. It's going till 7.
Yeah. We'll finish quickly, right? I mean, that's okay. Yeah, W3 schools.
Oh, we're talking, I'm in Queensland. Okay. So it is not 5 to 6 where you are.
Okay. Now,
correct?
Yeah, we're close to 7.
Right. I'm going to have to re-listen to the whole lecture, then that's what's going on.
Daylight saving changed on Sunday.
Yes, I did know that, but then I didn't actually piece it together that, hello, the trade's in Melbourne, and I am not.
Just one point in terms of W3 schools is that some of the SQL command, may not run in Oracle, but just check it, right? I mean, then you can get some other help in searching if it doesn't work. Anyway, now, if I put all the fields here, then we need to compare with E department number, which is this one, for example, this column, and the D department number is probably this one. So we have to write all combinations, and then whatever is same, we only pick those tuples. That is the join operation, right? And that makes sense. Now, in case of multiple query, one really important thing, which is that, for example, employee table works on and the project. So I want to print out the people, first name and last name, and which project they worked on. So definitely the works on is the middle one. We know that, right? Many to many. So it only has the project number and employee number relation. So to get the employee names and the project titles, we need to explore all these 3 tables. So how to explore? We need to join all 3 tables together, right? So now how to do that? So the way is that we need to follow the picture. I mean, that is one of the way, is probably the best way. So either you can go from here, from project to works on to employee, the sequence we have to follow, or from employee to works on to project, right? So here actually I'm using so select, you don't forget that. I mean, you don't need to write at the end, you can write from employee E, comma, works on W, comma, project P, right? In that sequence. And then where statement, you have to find the common attributes. So for employee and works on project, the common attribute is employee number. So E dot employee number equal W dot employee number. And what is the common attributes of these two? Project, right? So W dot project number equal P dot project number. So we fulfill that 3 relations and 2 statements, right? 2 clauses. 2 clauses. So, and then what? So now actually you can imagine that if we just do these 3 statement, then what we get the big tuples of, a big table. But when all these are same, so we are on the right phases, and there is no kind of non-meaningful thing. So all these are meaningful. And then from this big table, which has basically, you can imagine a big table of 1 2 3 4 5 6 7 8 9 10 columns. We only pick E first name, 3 columns, right? E last name and project title, and this is what we can get, right? Okay, so this is what the multiple queries is. So again, we have to follow that map and then do the equality. Now, interesting point, left outer join, probably I'll go more, some 5 minutes or 10 minutes more I need. Left outer join, right outer join, full outer join. It's a really important one to consider. So when we do the inner join, it will pick the common thing, right? Left outer join, the common thing plus all the attributes, and full outer join is everything, including common and uncommon thing. Okay, in the example, it would be clear. Now, in outer join, what happens in left outer join? So what happens in left outer join, right? So just try to imagine that from department D, left outer join employee, that we want to do, right? Where this department number is same. Now, a plus sign is an alternative way to define the left outer join, in which the plus sign, when plus sign is used on the right side of the clause, which means it is the opposite. So on the right side means I'm doing the left outer join. If I put the plus sign here, right, here I'm doing the opposite, doing the right outer join. So just other way around. This is one of the point to note. Okay, now what happens here? In that case, we try to equalize the number, try to verify that they're same phase. So we print that. In addition to that, if it is a left outer join, whatever attributes, whatever values in the department D didn't match to the employee, they will be printed at the end, right? So this is what is happening. For example, department on the left side, and I did the left outer join because the plus sign appeared on the right side, right? So ideally it should be here anyway. So D department name. So you can see that the first name, last name, department. So all these students have the department. So in the employee table, there was no employee who actually studied in physics and chemistry. It's a really interesting point. So when I did the left outer join, what it did, because department was on the left side, so it printed the common thing in both tables, plus whatever was not found as a common in a common tuples, we print that. So just try to think about these two tables. So all the students are in probably, if you compare it, in information science, computer science, but no one is in the physics and chemistry, right? So when you do the left outer join of the department and the employee, then only all this will be printed, and then physics and chemistry will also be printed. But since no student is reading in physics and chemistry, that these are null, right? These are null, and it has huge implication. We can identify that which fields, which data, they don't belong to any students. That is really easy. I mean, important to understand exceptional cases, right? In many situations, we need that. That is the.
Can I just ask a question?
Yes. Andrew,
at the top of the page there, you've got SQL and a particular select statement, and then you've got a different one in the example.
Yeah.
Are they just two versions of the same?
Correct.
Yeah. Okay.
Correct,
so
correct.
One is specific for Oracle, which is the one in the example.
Both.
They both can work. Okay.
Both. Yeah. This plus is exclusively for the Oracle, that I know. plus. But left, I really like this thing. Left outer join is really clear, right? To what's happening, to know. Okay.
Yeah, because the plus tells you that it's going to give you everything out of that table.
Correct. So it's the opposite, right? So this side means, yeah, you're right. On the other way. Okay. So okay. Full outer join, what it will do? It will do the common plus uncommon things, right? So just an example, I just did some extra examples here. Is that this is the department, this is the employee, and when I exactly do the left outer join with all the department, this example is exactly same as the example that I shown before, right? And then I see that I put all the things which are, which make sense when I do the, the join thing. And then finance and marketing, these two departments, no stuffs were there, right? So that will be printed as well due to the left outer join. Nicole, do you want to ask anything?
Yeah, just on the previous slide, I think it was on 56. No, sorry, the one before it.
Yep.
Yeah. So if you write in the second query, if you write E department number plus equals D department number, does that give the same result, or do you have to put it in the correct order?
No. The other way. So, for example, if it is a left outer join, right? So the position indicates everything. So you see that department D, I put the D here, right? And E here. So on the E, if I put the E side, which means department is on the left side. It's the other way.
Okay, so the order does make a difference. You have to write it in the correct.
Absolutely.
Okay.
Absolutely.
Okay, thank you.
If I want right outer join, I need to put the plus sign here. Then it will print all the common things plus the employees who are not matching, who are not matched in any department. That will be printed as well, right? Which means that these employees are not under any department, right? Really very practical, right? These things. Okay. Now again the same thing. So when I did the same table, you can experiment that all the codes on the and I did a online Oracle tool. So in Apex you can also try that. So when I did the left and the right outer join, in right outer join actually nothing was common, which means that all the employees are under department, so there is no null value. And in full outer join it will be exactly same as left outer join in this particular context, but in other situations you can find null in both sides, right? That also makes sense. Exists, non-exists. So in case of exists, what happens is that okay, this is an interesting one. This exist returns true if there exists at least one row in the inner query, right? We're dealing with the inner and outer queries, right? So for example, select something from employees. Look at this second line where exists and then first bracket, first end of bracket, select star from department and some clause, right? Something. So if it returns at least one tuple, then that will be executed. But if it doesn't return anything, then it will return null. The query will not be executed, right? So it is false if the subquery returns an empty result set. So that is the objective of the exists, right? I'm just quickly going through. So I think now very quickly, union, intersection, and difference. I think from set relation, we know that. Now I put some examples here. Union, when you put the union, the definition of union, if you can recall from the relational algebra, is that the attribute should be the same type and same number of attribute, and it will do the set operation. So when you do the set operation, then you should not do the duplicate thing, right? Now there are one thing is that there are two things. I just put it here. So if you put union, it will discard all the duplicate things, so no duplicate will appear. But if I want to retain the duplicate thing, that sometimes is important to know, right? How many is actually appearing, right? Then we need to put union all. So I made it clear here, right? Retain the duplicate value. So when I put the retain, union all, then it can retain the duplicate. Otherwise, with union, it will never do the duplicate. It is exactly the set operation. And what is intersect? So it will discard those, which are not in employee, right? Intersect, we know that from the relational algebra. Okay, so we did something. For example, if you see here union, we don't put any duplicate thing, but in union all, we have some duplicates, right? Thing here. Update, it's really easy. We can update a table based on a column. So for example, if you look at here, update a table, set first name, John, and where employee non equal. So we just, update the name, first name. Delete from table, the first name is that, so that tuple will be deleted, right? View, now it's, view is just a kind of temporary non-persistent kind of existence, right? So it is not a permanent. Table is a permanent thing. So view is sometimes you need to create a copy and show or do whatever you want to do, but it is not permanently saved. So just create view and then you can do that if you need to. I'm just quickly skipping and you don't need that. Just skip that. So I think in the lab, we'll go through all this that we really went through today. So yeah, thanks for attending, right? Any question probably during the lab we can take. Yeah, okay. Yeah, we'll see you in the next class. Thank you.
Thank you.